Okay, here we go. Oh, we're doing some. We're live. All right, here we go. Today, hey, not Owen. Good afternoon. Good to see you. Wow, you're fast. Look at you're first. You're the first one here. That's it's really cool. We're going to conclude today our Rust machine learning framework. We're going to walk through it. We're going to see all the details, understand kind of how it works, and then we're going to mess with it. We're gonna start cooking with some Threven and Throd demonstrations. I haven't ever done this before, but I think it will be kind of neat. What we can do is we can use this AI model to learn how to detect like odd and even numbers, but we can also have it detect Threven and Throd numbers. If you didn't know, yes, you can. This is a thing. It sounds like it's fake, doesn't it? Threven and Throd. It sounds fake, but it's real. It's a real thing. Basically, you can find numbers divisible by 3. And we can train an AI model, especially a deep learning model. And I believe it doesn't even need to be a deep learning model because that is it can be a linear model for sure. So, but we're going to do it with a deep learning model anyway. It's overkill. We're going to overcook the Threven and Throds. I'm really excited about that. That's going to be the plan today. I know we can get to it. Often we get, distracted and we, move off onto, tangents, but today we will get through Threven and Throd, and that will be the goal. We'll also walk through the XOR nonlinear example that was demonstrated. So that's the plan for today. What we'll do is we'll get started. So we've got here at the bottom of the screen, what I'll do is get rid of that, close this, there we go. We've got ourselves a nice list of files here. So we've got a nice list here, ls, let's see here, a bunch of AI files. Basically, this is all our Rust code, and it's all compiled, and it runs, I believe it's only for, hey, Ashford, good to see you. Welcome in. We're going to conclude today our Rust machine learning framework. We're going to see how it works, and then we're going to make maybe some modifications to it if there's time, but we want to play with it. We want to cook. We want to say, let's get it working with, let's train it on Threven and Throd numbers. Train it on Threven and Throd. I think we can do it. I've never done it before. I'm pretty sure it's possible, and we'll find out. It might not work. I'm pretty sure. I'm pretty sure it'll work. So let's jump in. So we've got some files here. Just to know, I believe the main RS is pretty small. It's just a run. It's like a throwaway file for the most part. So we don't really need to do much with that. But check this out. I do believe we were walking through the layers file in our previous stream, so we can kind of continue onward with that. Check this out. Okay. So this is the only layer that we have in all of our framework here. It's just the dense layer, which just means two-dimensional array, basically, multi-dimensional array, and with a bias. And so basically this is it. We're looking at it right here. These two lines is what it is. There are inputs and outputs. Hey, Jambuster. Hey, another day, another Rust project. Yep. So we're concluding today our Shurujin. Hey, hello. Good to see you. Happy to have you here. We're concluding today the Rust machine learning framework that we had, and we're going to walk through it really quick. We have time today to do that. We have time to walk through it. We're going to learn the details about it, and then we're going to use it. Then we're going to use it to build some toy models, and something I've never done before, but I'm pretty sure is possible, a Threven and Throd detector. We're going to write a Threven and Throd detector with the AI model. I'm pretty sure it's possible. We're going to find out. We'll try, and we'll see if it works. So, but we're looking right now at the dense layer, which is just a simple 2D matrix with a bias, which is a one-dimensional matrix. Yep. So you can see here how it works. So array with zeros, and then n number neurons. That's just like how dense is going to be this array. How many elements in the array is there going to be? But we call it neurons. I don't know why we call it neurons, or number of parameters or weights in it. Shrujin, hey sir, can you send the GitHub link? Sure, absolutely. I know we have it. We definitely have it. So it will be. Let's do this. Let's go to github.com. Stephen Blum. Here we go. Stephen LB. And then it should be around here somewhere. Repositories. All right, here we go. It should be at the very top. There we go. Rust machine learning. Here we go. Oh, is there? Oh, this is it right here. This is it. Sorry. I'll paste it in the chat. Tanmay. Hey, Tanmay. Hello. How's it going? Good to see you. Oh, well, all right. Your message got redacted. I don't know why that happened, but it does sometimes. But Tanmay, good to see you. Here we go. Check this out. We are going to paste this link into chat so you guys could follow along. And what I'm going to do is I'm going to move some of these windows around so I can see that. There we go. Perfect. I like that. Hey, hello, sir. How's it going? We're doing some Rust today. We're walking through some Rust machine learning. It's all CPU based. So this is like minimal like machine learning. We're not going to use any GPU acceleration today. Tenmei, great. Going great. Excellent. That's good to hear. We're going to walk through this code base. And then we're gonna play with it. We're gonna cook. We're gonna create a Threven and Throd detector. I know it's possible. I'm pretty sure. Vivek, hey, how's it going? Good to have you here. We are gonna jump into the code. So walking through it, this is the most important. If you're talking about where does the knowledge sit in the AI, where's the brain? Where's the brain? Right there, here on these two lines. On these two lines right here, we're looking at right here. The weights and the biases. The two-dimensional array here, and then a one-dimensional array with the neurons, which just basically means the number of elements or the number of parameters, Here we go. And then there's some nice things to have when you're doing training. You don't need most of this. Shurjan, hey, sir, are we team for Delhi Hackathon? Good question. Good to go. Definitely. Oh, see, Jambuster, if it's a CPU base. Oh, Love Gupta. Hey, good morning, GM Steven. Hey, how's it going? Jambuster, good to see you. If it is a CPU base and a minimum use of GPU, then I can use my project. Oh, you can? Yeah. Okay, perfect. Yeah, it's good to go. It is actually completely usable as is, and you can build the majority of all AI projects that you need with it. And so it is single CPU right now. I don't think there's any concurrency baked in because I haven't run into it, but you could easily bake in some concurrency, especially that you'd want like during training. During inferencing time, you don't necessarily need any concurrency. You probably could have, you just launch multiple instances. You could do forks. you can fork it. You do multiple instances. So there's no need. You just one process per container, and then you can get concurrency that way. But for training, we could make this multi-processed. Like we could submit the workload to train and then capture gradients from different threads, for example. We could do something like that to accelerate the training on a CPU style model. But you know what? If you've got a GPU, we could probably just use GPU compute acceleration with matrix multiplications. We don't want to do that today because we're just gonna mess around. We're just gonna have fun. So the brain is here, weights and biases, the inputs and outputs. THT, Stephen, hey, new here. Can you tell me in a few words, what are we working on? Okay. This is Rust Deep Learning using the Rust programming language. We have a minimal machine deep learning framework, basically a minimal deep learning framework. Pretty small. It's concise, and it has a few like extras for the training phase, things that aren't always necessary, but help accelerate it on CPU. So we're only using CPU today. We're not going to use GPU. And then once we walk through the framework that we have here, we're going to use it. We're going to cook with it. We're going to build a Threven and Throd detector. Threven and Throd. Yep. It's the subtitles will have a hard time with that because it's not a common word, but it is real. It's a real word. I promise you. Check this out. Threven and Throd. These are real words. It's Threven and Throd are a pair of informal, recently proposed neologisms of a mathematical community that extend the concept of even and odd numbers. Yeah. All right, so it's new, right? It's a new kind of thing. So we're gonna build an AI to detect those numbers. Isn't that cool? Ms. Elizabeth, hello, sir. I don't have any idea on what you're doing, but I really want to learn more about cybersecurity. Oh, that's a good one. There are actually some. This is okay. So that's the second time that that topic has come up. Cybersecurity. Usually, you want to have encrypted systems, right? When you're doing, especially in communication, where the majority of, which is what the cyber part is, where you've got machines talking to each other, you want to have encryption. And there's multiple kinds of encryption, including symmetric key encryption and asymmetric key encryption, which just means how many keys do you have. And you can have multi-part key encryption too, where you have more than two. You can split keys. You can split the keys up. And then you can have like 5 keys, but you need 3 of the keys in order to decrypt it. But you can split the keys across. It's a really cool pattern. I like it. Jambuster, what is that? Threeven and Throd is what we were talking about. Yeah, I think that's just basically like an even and odd, but divisible by 3. So we're going to build an AI to detect that today. That's what we're going to do. Tenmei, are we making a deep learning model using Rust can deploy that blockchains? Yes, you could actually. You totally could. So what is it? Solana and any blockchain that supports Rust or a WASM container. Of course, Rust can be compiled to most target binaries for any of the operating systems and platforms or like different processor types. WASM is a nice sort of like universal container that can run on most CPUs. So yeah, I think WASM will work. So you just target your Rust to compile to WASM, and you can do it. And so you can build an AI system that runs in WASM on the blockchain. Now, guess what you've just done? You know what you've just done, Tanmay? You've created an AI inside of the blockchain. That's what you just did. And you can totally do that. And you can do it with this repository as well. All you have to do is target WASM, and then you can deploy it onto like the Solana blockchain, for example, or any of the blockchain with smart contracts that support WASM. Or maybe any other kind of binary that Rust can target. Okay, so jumping back into here. So there is a nice to have, but we don't need this method here. It's just kind of a throwaway method, but you could if you wanted to. Tenmei, cool. Yeah, absolutely. This just lets you predefine your own weights and biases. And you might want to do that if you want a different kind of distribution. For example, a random uniform of numbers in your matrix between -1 and +1. This is kind of interesting. So what I found is when you are creating AI models, you want to have a uniform random initial weight activation and biases too, really. Although in this case, it's not happening here, but it's got to be between -1 and +1. Milan John, hello, bro. I'm back. You do too. I'm sorry if I couldn't watch your last live. Hey, all good. We're gonna have a little bit extra time today. We are gonna get to go through, and we're gonna have the capability to build cook with. We're gonna cook with this model. We're gonna build our own Threeven and Throd model. Basically, like it's detecting even and odd numbers. Nazar, hey Nazar, how's it going? Happy to have you here. We're working with Rust today with a machine learning framework. It'll be deep learning, and we're gonna walk through it really quick. So that's what we're doing right now. We're walking through the Rust deep learning framework, and we will be. So what are we doing today? Yep, Milan John. That's the plan. We're going to be walking through the Rust deep learning. Hey, thank you for the likes. Appreciate it. Woo, love it. So good. What programming language are you using? This is Rust. This is the Rust programming language. Rust has the performance of C, but it's got extra benefits that most languages don't have, including concurrency safety and memory safety. Now, you might say, hey, Stephen, hold on a second. I heard that Java and some other languages have these safeties built in, but they only have them built in at runtime, and they don't have it built in at compile time. That's where Rust is special. Hey, thank you for the likes. This is why Rust is amazing. It builds it at compile time. It checks all of the concurrency problems that you'd run into and any of the memory challenges. But it's hard to work with, so it's really strict. Thank you for the likes, you guys. I appreciate it. I get every time you click that like button, I see it like floats up with an animation there. All right, so here we go. Love Gupta, for sure need some mentor like you in my Rust journey. You are the good at Rust. Yes, really good. Absolutely. So we use Rust at PubNub for connecting our devices. We have over 1 billion connected devices that communicate for things like, we're going to chat. Thank you for all the likes, everyone. And so we've got to have expertise in Rust. And so we use it to just distribute our binaries across Kubernetes and containers across all of Amazon's availability zones across the planet. So your device connects to the closest region, so you get the fastest performance. Yeah, thank you for the likes, you guys. Appreciate it. Great. What type of LLM are you about to build? We are building a basic machine learning. We're not going to be building generative AI, but we can add a self-attention on top of this, and then we can also have the outputs be a softmax across a bunch of different token outputs. And so we could build an LLM if we wanted to using this very framework. It's not that far off. All you have to do is we could do like a letter-based, so an alphabet. So just like what A to Z, for example. Thank you for the likes, you guys. Appreciate it. So we could build an LLM if you wanted to using this very framework right here. It's not very far off. You can totally do it. Yes, a mentor like you, excellent. Can we use a tan-h activation function, but is there a predefined module in Rust? So yeah, you can use tan-h, and we have an activation here. Check this out, activations. We have a tan-h here. There you go. And it's using, I do believe it's called, it's a built-in tan-h, which is coming from ND array. It's called ND array. So you can use ND array, and it's got built-in math for that. It's kind of like NumPy in Python, but it's for Rust. Yeah. Where are you from, bro? Milan. Good question, Milan. I'm from USA, United States, Seattle, Washington. That's where I am from. I was living in San Francisco. Then I moved to Seattle. So that's where I'm at now. And I miss the Google Fiber that I had in San Francisco. It was so fast. Hey, MD. Hey, Steven. Nice to see you. Thank you for the likes, everyone. Nice to meet you today. Need some suggestions. Oh, okay, MD. Let me know what these suggestions you are referring to. Nazar is RNN or CNN. So RNN is recurrent neural network, and CNN is convolutional neural network. They're just sort of different patterns. RNN has an extra built in for each of the neurons, I believe, that has an extra state associated with feed forward. And with training, which allows you to have sort of like, it has more memory based on and CNN has filters. So that way you can have a different sort of look at all of the edges within a photograph, for example, or some sort of vision. You use CNN for vision usually. And you can have a number of filters, which is basically a layer. It's just another layer. And what is a layer? A layer, if you remember, is just an array. It's a multidimensional array. That's all it is. It's really simple. All these fancy words, right? Jambuster, thank you guys for the likes. I can see all these likes. This is really cool. Love it. Thank you. Jambuster, can an AI like GPT-5 with quantum computing can decrypt the really strong blockchain systems? Okay, here you go, Jambuster. So you can decrypt, yes. So the factorization is one of the strong points. So there are quantum proof algorithms. And here's the good news. If you are into blockchain and you're worried about a quantum computer cracking like Bitcoin algorithm, guess what? It can do it. It will. It can crack it. And you got to be careful because the machine, they need to be more powerful. But there's good news, everyone. There are algorithms that are quantum proof, and we can fork the blockchain to have like a cutoff point to where it only accepts the new algorithm across the fleet of all the connected distributed compute. So we're good. We're safe, you guys. We're safe from quantum computers. We don't have to worry about it. We're good to go. And there's a plan. There's a plan. We're safe. We're safe. MD trying to integrate something with wallets as of ZKP. Ooh, interesting. That does kind of sound interesting. Which kind of wallets? I guess probably a crypto wallet. Nilspin. Have you played with SlangD? I haven't played with SlangD. Let's check it out really quick. Let's see what that is. I don't even know what SlangD is. Let's find out what SlangD is, you guys. We're going to learn today. We're going to learn what SlangD is. SLANGD. What is SlangD? So it doesn't know. The internet doesn't know. What is this? Is this it? Is this something? Oh, SlangD is a shader language providing fast. It might be this. It's probably because it's relative to our topic. So I'm pretty sure that's what you guys are talking about. All right. Love Gupta. I'm learning Rust in public. And I'd love tag on Twitter you along so you can stay responsible, consistent, and accountable for my... Yes, do it. Absolutely. Happy. Let's make it happen. So, see, x.com/Stephen LB is my Twitter or my X account. So if you want to do that, feel free to follow or chat with me here. I'll respond for sure. I'm not super active on Twitter. Usually more on YouTube, right? We're on YouTube here. So there you go. That'll work there. Snehan, hey, your video is great, but could you create a real Python course, like explaining the concurrent code execution process? Great, thanks. That would be a really good one, Snehan. Oh, Snehan, that's a really good one. I love that because Python has the global interpreter lock, and they do have a version where you can disable it, but you'll run into problems. What you want to do is you want to use something like multiprocessing or MP to fork the Python workload and then do message passing between each of the workers. And then you can do concurrency that way. It's my favorite way to do concurrency. You can do threading in Python, but it won't give you multiple CPUs. It'll only work on it's sort of like an interrupt for network I/O. So if you want to do concurrency for network I/O, then you want to use threading. But if you want to do CPU concurrency to leverage more CPUs in Python, you have to use something called multiprocessing. It's called multiprocessing, and that's what you want to do. And it does a really good job. See here, getting caught up with the chat messages, and then we'll get back to the framework here. We want to get back to our framework. Nasser, thank you for the explanation, sir. So what kind of model are you going to build with it? CNN, RNN, or LM? This is none of those. It's none of them. It will be just a standard sort of multi-dimensional regressive model, or sort of like a support vector machine. I think it's more along SVM is what we're doing, but with a dense SVM. That's what we're building. Here we go. Dense SVM, support vector machine. That's more along the lines of what we're building. And it's just a simple version where it's just the weights, it's just the biases, it has the activations, and then it does a forward pass, and then we can do back pass in gradient, using gradients to train the model. That's what we're going to do. That's what we're planning to do, you guys. Do you have Insta? Yep, same. It's the same Insta as Stephen LB. Stephen LB on Insta as well. So Instagram, Stephen LB, I think. Is it Stephen LB? Yeah, here we go. That works as well. You can go to that one, and that will be the Instagram. There you go. Stephen LB on Instagram. Let's see here. Let's jump back in. Yes, sir. The slang difference slang. Meant to ask whether you have experience with auto diff. So if you don't have to write backwards past yourself on, that's interesting. I don't have experience with auto diff. Let's see here. Let's get back to the programming language here. But AutoML, yeah, that makes, I played with AutoML, but AutoDiff might be the same thing, right? It might be similar. We'll have to look it up later. MD, so you're saying, hey, you're a self-learner, you love technology, you know C, you know Python, but you don't know what language is for blockchain and ZKP. So, right, what was it? Solidity. Solidity is it's kind of an ECMAScript style language. It's kind of, I think it's for the Ethereum framework or the Ethereum network. But Rust is really good. Rust is actually supported, I think, in Solana, and it's probably a really good. And C, you could use C as well and target WASM, I believe. Mohammed, hey, how does Rust connect to deep learning? Well, so deep learning is just, essentially a set of algorithms. And all languages, including JavaScript or TypeScript or Python or no matter what, C, C++, Kotlin, Java, you name it, Elixir, all of them, they can all do deep learning because it's just a simple algorithm. It's not too complex. But Rust, Alfie, Rust, love. Yes, you love Rust. Just subscribed, bro. Oh, yes, thank you. I appreciate it, Alfie. Good to have you as a subscriber. I appreciate it. We will be doing these lives on a regular basis on the weekdays. On the weekdays, we'll be going live once a week or once a day per week. No, wait, let me say one time per day, 5 times per week. So if that makes sense. Or sometimes it'll be 2 times per day, but usually just once per day when I have time because I have meetings and it's sporadic. So I'll be going live at different times. because I have meetings throughout the day, and then it changes. I have different meetings that show up. So I don't have a consistent schedule. But yeah, subscribe and you'll get notified. We also have a Discord. And then if with the Discord, you can also get notifications of the live as well. So I'll paste that. Join the Discord and you will be able to also get notifications. Here we go, the Discord link. All right, see what else we got here. Rust is the best programming language in the whole history of the universe and multiverse. It is, because I think so. Here's why. Because we've got a business, PubNub, and we use it to connect over 1 billion devices, and we use Rust. And Rust has saved us so much performance. It has netted us a huge amount of win on latency. It's like a 10x difference. It's huge, especially at scale. And it's phenomenal. It's like the $1 billion language. Why is no one else programming in Rust? Because the compiler is so strict, and it has all the checks up front, including memory safety and concurrency safety, and it's just really fast. It's as fast as C. It's really cool. Yes, I started. MD, yes, you started learning Solidity. Excellent. And I'm confused and should learn Rust and Go too. So it depends, MD, what your objective is with your smart contract. What do you want to build with your smart contract? That is what you kind of want to sort of consider. Bro, do you use LinkedIn? Yes. We do have LinkedIn. It's also Stephen LB on LinkedIn. LinkedIn / Stephen. Is it in here? Let's see here. I think LN. Here we go. We'll pull it up here. Oh, all right. Here. Stephen LB LinkedIn. That's it. That's all you have to do. You have to search for Stephen LB on LinkedIn. Then you'll have it. Is this it? This is the one. Okay, perfect. This is perfect. This is it. Okay. Arian, hey, I'm new to your channel. This is the first time I'm here. On what profile you work, and how much experience do you have? On what profile? I suppose you can get some of those questions from the LinkedIn. So you can see I've got some patents. I've got some patents registered. You can see kind of my history. So there's like work history, those sorts of things. You'll be able to see that on LinkedIn. There you go. I hope that answers your question there. Alfie, I wrote an OS macro kernel or microkernel in Rust. Did you an OS microkernel? So something that can handle sort of distributing work between processes or threads on a machine that's probably like an RTOS of some sort. With Rust, AI agent microservices with dedicated runtime in each could literally automate my whole computation workflow. So that's really cool. Okay, so you've kind of written your own orchestration, essentially is what you're telling me, Alfie. That's actually really powerful. Jambuster, you believe in Rust and C and its compute super fast capabilities? Yeah, it is. And storage to create AI models from scratch. Yeah, but it's not a beginner friendly. It's not. It's one of the hardest languages to learn, in my opinion, other than like say maybe Haskell or Lisp. Those languages are challenging. Haskell and Lisp are challenging languages, but yeah, Rust is probably the most beneficial to learn by far. But you're right, Jambuster. It's not a beginner-friendly language. Hey, Shyam. Hey, Steven, how are you? Doing good. We're walking through our Rust deep learning machine learning framework here, and we're gonna cook with it. We're gonna use it, and we're gonna build some toy models, and we'll show you how it works. We're gonna walk through it. So we mostly got through it here. Love Gupta. I've subscribed for your lifetime. Excellent. Thank you. Just like a Rust lifetime, I'll stay bound to Steven's YouTube programming teaches in the end. Cool. Goal achieved. Excellent. Thank you, MD. Thank you, sir. I was wondering here and there for my answers. You are awesome. Thank you. Appreciate it. Alpha, yep. That was one of the most incredible things I did with Rust and made me extremely in love with Rust because you can literally build anything. You can totally build anything and it will be fast and from your brain and a neural network to a microkernel and it all. Yes, and you can build and you can deploy to IoT devices because of the low footprint. You can deploy it to the blockchain. You can deploy it into the web with WASM. You can build games like AAA games. You can build a game engine with it and launch a AAA game with Rust. It can do all the things. It's such a beneficial. Soham, hey, how's it going? What IDE integrated development environment are we using? This is Vim. We are using Vim today. So we see here. So Vi, here we go. So we are using Vim version, here we go, version 9.1. This is version 9.1. Vim improved. This is the IDE we are using. If that answers your question, I do believe it did. Here we go. Let's jump back into the code. All right, I love speaking neural network more than ANN. Yes, this is kind of like an ANN, to be honest. A neuromorphic AI. That sounds interesting. You use Arc, by the way. Arc Linux. Arc Linux, that's a great distro. I love Arc Linux. Hey, official Army Gamer. Hey, how's it going? Alfie, NeoVim. Yes, NeoVim. That is also a variant of Vim. It supports Lua as the scripting language and has more plugins for the ecosystem. Because Lua is a lot easier to use than the Vim scripting language by far. All right, Rust is a language that makes me believe I can build anything. Yeah, it really is. It's just so good. I love it. And it was one of the most difficult things to learn, but it's absolutely worth it. MD Alfie, you use Arc with DWMBDW. That's cool. That's a good combo. Arc Linux from scratch. Excellent. Oh, what? Really? Wait, why? What? Alfie, wait. You built it from scratch? That's kind of impressive. That's very uncommon. Usually you just download the pre-compiled distro. Good job by building it from scratch. That's amazing. If you would start over, how would you learn machine learning? I would use Python, and I would start with a support vector machine. Let's do linear regression first. Use Python and NumPy, and then do a linear regression, and then do a support vector machine, and then do deep learning. That's the way I would do it in that order. I think that's a good combo. Excellent. All right, so let's jump back into the code here. So we have our activations here at the top we saw. We've got TANH, sigmoid, and ReLU. That's all we need. We don't need any others. Okay, and we've got our dense layer, and we've implemented the dense layer with a forward pass and a back pass. Forward pass is to get our inference so we can detect what the outcome is, and then the backward pass is for training. And these are all helper functions here, and that's it for there. All right, we're getting through it, you guys. All right, let's open up losses. This is how we detect how wrong the model is. When a model makes a prediction and we know what the answer is already, we can calculate how wrong it was. It's like, hey, model, you predicted this answer, but you were wrong, and you were off by 10, for example, by a quantity. Then we can take that loss and apply it in back propagation to the model's weights and apply it based with a learning rate to slowly adjust the weights to make it learn. That's how the model learns. Is really cool. Not from scratch. It was Linux, but Arc is very flexible and customizable that you have to install it manually and do all the heavy stuff. But the kernel is Linux. The Linux kernel made by Torvalds, of course. Yes. Linus. Got our Linus who made Linux. Here we go. Mean squared error. Okay. Interesting. Oh, neat. Okay. I see kind of how. So it's you can. I wasn't aware that you needed to have loss for back, I suppose, to calculate the gradients. So you've got a forward to calculate loss, but then the gradients back. Bro, to build, what's array 2? Oh, right, Nirjar. Array 2 is a two-dimensional array. If that answer is, it's two-dimensional array, basically. An ND array is sort of like NumPy, but for Rust. ND arrays like NumPy, but for us, because it's got built-ins that make it a little bit easy. But NumPy is better because I like it a little bit better because it has some nicer syntactic sugar. But Rust can't get to all of it. It can only do a little bit. It can do just a little bit, but not as much as Python. Let's see here. Bro, you built your personal assistant with Python, which is another combo will be better, bro. Oh, really? To build your personal assistant, yes, Python. Definitely use Python for those kinds of projects because it's easier to maintain and build and read. This code you're seeing on the screen, there's a lot of symbols everywhere. There's a lot of ampersands. There's like angle brackets. There's semicolons. There's arrows. It's just a lot going on here. But it's necessary for the compiler. But you don't need that if you're using Python, which is really cool, right? We could have used PyTorch for Rust. There is a PyTorch-like. You can use libtorch. So Alfie, libtorch is the C++ library that PyTorch uses. You can also use that in any other language. You can use essentially PyTorch or libtorch in Rust. You can do that as well. And we might even do that because it gives you the ability to access the GPU to accelerate the compute of your AI. So that's one thing. Your Vim config looks interesting. Share vimrc. Okay, here we go, guys. We're going to share the vimrc. I love that Vim is everything. Yes, we'll do a vimrc on the screen. You can take a screenshot. So vimrc. Here we go, you guys. Vimrc. All right. Scroll here so you can see. This is the vimrc. Excellent. All right. So I've got a lot of undos. I've got a built-in copy paste that lets me copy to the local operating system buffer. And then I've got, some groove box is my color scheme. So I think those are the coolest things. Everything else is just, standard stuff. You definitely want HLS enabled because that lets you, like, for example, you can highlight all the same characters or same string. I like it. Linux is basically awesome. You can't live without it. Yep, it is so good. That's what I probably move to Linux. Right now I'm running on Mac OS, which is Unix based, so it's close. Is your code open source? Can I have a clone of it? Yeah, it's open source. I'll paste in the window here your link to the open source project. All right, here we go. Let's paste that in. Here's the open source code for you guys. You can have it, and guess what? This will work in any environment. It'll work in WASM. It'll work in smart contracts. It'll work for wherever you want to deploy it. It works everywhere. It's universally supported, and it has almost no dependencies. So it's really efficient, it's lean, and it's powerful, and you can cook anything you want with it. It's really cool. It's really cool. What are you building with Python? Oh, Joy Kid, sorry, I missed your message. Use Groovebox on your NeoVim. Alfie, yes, Groovebox is my favorite color scheme. Groovebox is the color scheme of choice. There we go. So you got Groovebox. Yep. Let's see. Jumping through the chats here. Linux, open source. Yep. Wait, deep learning with Rust. Yeah, quantified quantum. You can totally do deep learning with Rust. You can absolutely do it. And we did it. We actually did it. And you want to do that for things that are like non-linear things to learn. For example, the XOR operator, which is a non-linear operator. You can do that. And that's what we did. That's what we did here. But here, close that. We don't need that anymore. All right. So we just looked through our losses, which is mean squared error. Let's see here. Getting back to some of the chat messages here. I'm sorry. I'm catching up, you guys. I see your chat messages. I'm just trying to get to them all here. Yeah, libtorch is amazing. It is. Alfie, you're totally right. libtorch. Open source. Oh, I pasted the link. Okay. And for Joy Kids, hey, for how long have you been coding? Decades. 4 decades since childhood. Once I got in, it was really scary. Computers can be really scary, you guys. You press a button and they beep at you, and you make an error sound. So computers can be scary, and I was scared of computers. So then I took my fear, and then I just ran into it, and I found everything you could do with a computer. All the things, networking, distributed compute. It's all this stuff. Thank you for the likes, you guys. Appreciate it. There's a lot of stuff you can do. Decades is the answer, Joy Kid. Soham, hey, do you think Go here is a good language to learn, or should I go with Rust? Okay. Go versus Rust. Golang or Rust. There's a difference between the two significantly. Golang will have touted the concurrency safety and memory safety, and it is a web server-based language, so it's built for building APIs, and it has all of the the majority of the HTTP frameworks built in as native packages. So Golang is good for that. It's okay. It's pretty fast. It's like, maybe the speed of Java. It has a memory garbage collector, and it has pauses. At PubNub, we could not use Go because it is not fast enough for us. It is not a fast enough language. We have to use C or Rust because we have 1 billion connected devices. So Rust or C are the only options for us. At our scale, Go is just not quite fast enough. But it will work, and it'll do the job, and it gets things going quicker. So choose Rust or C is my recommendation. But Golang is also fine. I would recommend Python, though, in that case. If you're going to choose Go for a project, you might as well use Python. Let's see here. Interested in, but you're not sure. All right, so I'm almost caught up with all the chat messages, you guys. Official Army Gamer, bro. I have interest in LLM, but how to start, bro? Any examples or ideas? Yeah, so the best way to get started with building your own generative project would be PyTorch Transformer. Here we go, PyTorch Transformers. This one. This will get you started with your. This is probably like the easiest way to get going. And then it will give you all the, it's like the bidirectional transformers. You could GPT, generative pre-trained transformers, vision transformers, all these transformers. This is where you'd want to go. And plus it has frameworks built so it can run on hardware acceleration, because you kind of need it, because you need a lot there. And then you can build your own. You can build like a clone of yourself even, right? You take all of the text messages you've ever sent, and then you train the LLM on it, and now you've got yourself in a box. You can do that. And this, a PyTorch transformers is what you want to do. This is Meta or Facebook's technology, and I believe OpenAI and Anthropic use it as well. Yeah. So see here, Alfie, let's build an SNN in Rust, a brain-inspired neuromorphic neural network named Spiking Neural Network. Oh, Spiking, I remember Spiking Neural Network, which it can train and works on a single battery instead of millions of GPU clusters. That sounds cool. That sounds really cool, Alfie. That is like sort of like the dream is, how do you get an AI algorithms and the hardware and all the technology to be as efficient as a human brain? Because a human brain, it got a billion, basically a billion weights, but each weight is kind of more on the line of a quantum computer style, because your neurons are really small and really tiny, but they also activate in random patterns that are kind of interesting. And so in order to emulate that, that's what you can emulate that on a computer, but you need more. We're not there yet, guys. We're not there. Bro, you sound like you can talk for hours without feeling any exhaustion. Well, I eat very well. Like, I'm telling you. Here, I took some pictures of what I eat this morning to show you guys. Is your diet like this? I'm actually just kind of curious. Do you eat like this, you guys? I don't know if you can see it. We'll see if that shows up on the camera. That's what I had. That's what I have. That's what I made for breakfast today. Yeah, there you go. I just took some pictures there. If you eat like this, you will feel good and be happy. I'm serious. That's really what breakfast was. Hey, Rutik. Hey, how's it going? MD, your BIM-RC looks the same as me. Minimal, yep, but powerful at the last line. Something different. What's that for? Let's find out. MD. Let's take a look. Really quick. Okay. All right. So we have Copilot. Look at that. I have a Copilot, and I've selected GPT-4.1 Copilot. I should probably, you have a good eye. I should probably unset that, you guys, because that is an old model at this point, isn't it? Isn't that an old model now? Let's do that really quick. Let's do vi_vimrc, and let's get rid of that .vimrc. Here we go, and then we need to comment that out. With a single quote character. It's like a double quote line to comment that out. That was for Copilot. So this was for Copilot here. I hope that answers your question. There's also some status line stuff that I don't use, and then some extra file types that allow syntax highlighting. I think I do believe this allows syntax highlighting. There we go. Let's close that. Thank you, MD. I think you just made our lives better today. Thank you. I appreciate it. Let's see here. Jumping back into some of the chats. ICSP doesn't consider Python. Cool with sunglasses. ICSP doesn't consider Python. What do you mean? Cool. What do you mean by that? How do you get your first Rust job? Well, get experience with Rust and then start applying for Rust positions. And here's the good news. Rust still has a, what do you call it? I suppose you could also apply for C jobs or Python jobs as well, or any job, because you can use Rust. We did another stream recently where we showed how you could use Rust in any other language. Basically, we showed how to use it in Python. So you can write your code in Rust and then call your Rust code from Python, for example, by compiling a Rust library and then importing it into Python. So you can do that as well. So basically, if you want to use Rust, you can do that with any language for the most part. If that answers your question, Hey, Brain, how's it going? AI, yes, artificial intelligence. Brain Tenny. Alfie, I thought about it. Would really love to create a perceptron transistor. Ooh, there we go. Now we're getting into it. You guys. Perceptron transistors, software to neuromorphic computing on a software instead of building it with physical and be limited by physics. There are brain computers, and you can lease them for compute. They're available. You can lease a quantum processor to compute, and you can also lease a real neural brain chip as well, which uses real human neurons that have been grown in a lab, and then you can use that to train. And so that's where we're going next. That's like where the innovation is going to happen with AI will be in quantum. I think we'll have a huge leap there as well with quantum. That will be really cool to use like the quantum computing for AI learning. It'll be amazing. Brother, for LLM, Python is okay, but other languages, which makes it very more easy. LLM, I think Python's okay. Python's a really good language. Official Army Gamer, Python is a great language for LLMs, and you can. It's for the most part, you're leveraging. Libraries underneath it. So Python isn't doing the heavy lifting, but like things like PyTorch, which is libtorch, will do the heavy lifting because that's written in C, but you're actually calling it from Python. So Python works really well for that. And it's also really easy to use. And it's probably why it's one of the languages that are really prominent in data science, because you get the powerful compute of using these libraries that have been pre-compiled for you. And you can leverage Python, which is a simple language. And so it's a win-win. Easy to use, and then fast and powerful at the same time. Really powerful. And Aruga, hey, how do you record yourself together with your screen? OBS. It's called Open Broadcast Studio. So I'll show you here really quick. So I don't know if you can see it. Can you see it, you guys? Here we go. So you can see it up here at the top. OBS. So you got your chat over here, and then you've got your OBS. So you get to do a screen capture, and then you've got your camera, and then boom, you're good to go. That's kind of how that works. All right, getting that back over there. So many questions, you guys. Want to get to the code here today. It's going to happen, I promise. I really want to build a Threeven and Throd detector AI. I really do. Let's see. I'm going to open up models so we get that up on the screen here really quick. Getting through some of the chats here. How do you some of the scrolling is happening. I only thought Python or R had libraries for ML. Every language has machine learning code. JavaScript does, right? JavaScript, TypeScript, Rust, Kotlin, Java for sure. I mean, you name it. They all have, because it's just simple math. At the end of the day, it's just simple math. It's mostly multiplication is what's happening there. And then a little bit of extra constraints with the activations to help prevent the model from exploding. So yeah, it could any language. Hey, 30C2. Hey, how's it going? Happy to have you here. Alfie, fascinating. Yeah, absolutely. Energirl has said, hi, hey, how's it going? How do you, okay, yep, got already that one answered. So many questions here. Open Broadcast Studio. Yes, you got it. And then now we're here at the bottom. I had some real interest in AI ML as a fresher, but all the Kaggle hackathons kind spoiled the fun for you. Did it? So yeah, I guess, yeah, because the Kaggle hackathons, you're going to have really well-seasoned AI engineers who know their algorithms really well, and they'll be able to, get to the leaderboards a lot faster. So that's it. Is it within YouTube Open Broadcast Studio? It's a separate application. You just download Open Broadcast Studio onto your machine. It can run on Windows or Mac or Linux. And then you can just get things set up. There you go. Curious World. Hello, friend. Joined this late. Do you find advantages in using Rust for ML compared to Python? Yeah, because Rust is a lot faster. And especially if you're going to be building with things like, what do you call it? Maybe simple machine learning models. Or deep learning models, Rust is going to give you more performance. We did a comparison. We actually had a previous live where we compared Python and Rust for machine learning, and Rust was 2 orders of magnitude faster compared to Python. And it was impressive how much faster Rust is compared to Python. It was like 20 times faster. It was amazing. So yeah, you'd want to use Rust. That's why you'd want to use Rust. Also, it's got built-in checks and the compiler is very strict. So it's a little bit easier to prevent you from making mistakes. But it is not super easy or friendly. So that's a drawback, right? For Rust is a challenge. It's hard to use for sure. But yeah, there you go for Rust. Specifically with LLM workflows such as LangChain, for LangChain and frameworks like that, you want to use Python because it's just easier to get started. And they do have a lot of libraries that are imported that are pre-built for you in C. And so you still get a pretty good, decent amount of performance with Python and LLMs. So yeah, just use Python there. I think it's just easier to get started. David, hey, how's it going? I'm really inspired. Love your work. Thank you. Excellent. Great to hear. Kaggle Hackathon, who can join it? Everyone. I think it's a globally available, always available, a hackathon. Anyone can join. There's no restrictions. Please suggest us. Absolutely. Feel free to join if you want. That works for anyone. See here. Alfie, what is the number in many know it? What is a number that many know? And man, he knows a number? Asked the creator of a neural network. Is this like a saying or a riddle? Some sort of common phrase? Sort of like a thing, or like a, what do you call it? A Turing test of some kind? Hey, I want to learn machine learning AI with Hey, AI. Okay. Hey, you want to learn AI machine learning? What should you ask for beginner? You're very confused. Okay. Start with linear regression, maybe. I think linear regression is kind of like the entry level AI, and then do support vector machine, and then do a deep learning. I think that's actually something like that. It's sort of go on that path. So linear regression first, then support vector machine, SVM, and then you can do deep learning. I think they're a little bit more straightforward. Let's see here. I'm here the first time and love your broadcast. Excellent. Anna Gurl. Hey, happy to hear it. Appreciate it. Love it. Curious World. Appreciate you, Stephen. LangChain is for creating LLM AI agents. It is. Yeah. LangChain is meant for specifically orchestrating the use of agents. And so you probably want to use Python for that. So if you're going to orchestrate, you're going to use like multiple agents, multiple models, and then you can essentially chain them together. So you can do work on one model and then take that work and then apply it to another model. So LangChain, right? Chain the models together. But yeah, you'll want to use Python for that. That's the way to go. Let's see. Many open source, many courses available. So yeah, that's the trick. I recommend just going on YouTube. And then having someone walk you through it so you kind of have like an idea or picture, and that will kind of, it won't give you as much knowledge as if you try it yourself with your hands. Like jump on the keyboard, and you will learn more. That's what I do, but I also use YouTube. I just use YouTube and I go on there and I watch different videos, and you learn what's possible by doing that. And then you can jump into the coding, or you can do it at the same time. It's kind of up to you guys. That's the way to go. 30C2, like there's anything out there for people who are interested in AM but not want to go for a PhD or research. Then you'll want to use a framework. You probably want to use a framework. You might not need to learn the math behind it. Keras and TensorFlow are pretty easy. PyTorch is a little more challenging, but it's going to give you the more power. But it requires you to do more work. But Keras, I recommend Keras. Here, let's do this. If you really want to do your own AI, Keras and TensorFlow. Here you go. Want to do Keras and TensorFlow? I think this is probably one of the more easy machine learning, and you can use Python. You can use Python with it. I think it's one of the more easier deep learning frameworks out there. It's simpler, offers simpler and consistent interfaces. There you go. That's my recommendation. Linear regression, support vector machine, and then you can do deep learning or just standard machine learning. And so that's what we're doing right now. We're doing deep learning today. That's what we're doing today. We're doing deep learning. YouTube. Okay, good. Yes. Support vector machine. Yeah, absolutely. And deep learning. Learn everything from YouTube too. Yes. That's the way to go. YouTube is the place to go. That's where I taught, as a self-taught, you want to find all the possible ways that you learn. And YouTube was one of the most important ways that I used to learn programming at the very beginning, way back in the early days when YouTube was just getting started. It is, but beneficial learning code with AI. Yeah, it is. Is it beneficial learning to code with the AI AGI? Yeah. So you could use like ChatGPT to help you learn as a coach as well. So that's also really beneficial. Tell you what, even after decades of coding experience, distributed compute, artificial intelligence, I'm still learning more every day. And the AI, it teaches me a lot. I was like, you can do that? It was teaching me things I didn't even think you could do. So yeah, absolutely. As much as you can, leverage the chat GPTs and the similar coding agents. You'll get a lot of experience. YouTube is the best teacher, building small projects, but I would start small and learn Python. Python is really good. It's the best. And then even learning with N8N before LangChain. N8N is great because it's visual. It's drag and drop, and you get basically the same experience with LangChain, but in a visual way. N8N lets you connect to different systems like Salesforce or maybe your Google Calendar or your inbox or your any sort of existing system that they have a bunch of built-ins with it. So N8N will be great for that if you're looking to do less coding, but you still want to leverage the power of LangChain. That's a really good recommendation. Wait, who recommended that? Hold on. Who recommended N8N? Let me double check, because that was a really good recommendation. Let's see. I'm looking here. I'm scanning. Wait, who said that? Who said N8N? Best teacher out there is small projects. You said, hey, and girl. Oh yeah. AI said hi. Hey, how's it going? Just trying to look through all the chat messages. N8N, excellent. Someone recommended it. I can't find your chat message now, but good job. It's a good one. Yeah, it's a good recommendation, you guys. Excellent. Let me scroll back up here. Yeah, I kind of lost that message. It's gone. I don't know where it is. But thank you for whoever recommended N8N. It is really a good recommendation. PyTorch, TensorFlow, what they do, library, that what. And Gruel. So TensorFlow and Keras, which is a higher level API on top of TensorFlow, lets you do deep learning. And then PyTorch is the same thing. They're competitors. So you can choose but they achieve the same outcome, absolutely the same outcome. But Keras, I would say, is easier to use. So do Python and Keras if you want to do deep learning. It's easier to use. It's everything's sort of baked in and built for you. But PyTorch is more advanced. It's more powerful, and it's I like PyTorch. Like, I prefer PyTorch because it gives you more control. It's a lot more control. So do PyTorch. Definitely do. PyTorch is the way to go. Definitely look for PyTorch. But it's more advanced. It's more involved. N8N is drag and drop. Absolutely. Will code jobs disappear in the near future because of AI? Yeah. Well, right in the near future, yes, but in the far future, no. I think we're going to see an increase in the need for more software engineers because we're seeing so many people who even are not coders write code now, and they're finding it difficult to maintain the code bases because they don't know what to do with them anymore. And they need a software engineer to come in and help untangle the mess. And yeah, these AIs can jump in and they can edit and modify existing code bases. But once they get to a certain size, the AI, you need to have a different skill set to be able to manage the code base while still using the AI. You can still use like Claude Code, Codex, and Gemini to manage and maintain very large code bases. You just need more background in software engineering to do that. And that's what we're going to see. We're going to see an increased need for software engineers. That's what happened with spreadsheets. So back in the day, spreadsheets, they used to be done on a piece of paper on a really big table. But then the computer came out, and then like Excel, right? The digital spreadsheet came out. And then 400,000 spreadsheeters lost their jobs because they didn't know how to use a computer. But then the jobs for spreadsheet workers, it became so much more accessible because you could do it on a computer. It grew to over 1 million jobs. Isn't that amazing? So we'll see the same thing with software engineering. You would complete your bachelor's in 2027 as a fresher. Should I completely focus on machine learning or just go for some kind of development or maybe for a master's? I recommend bachelor's is good. Prompt fail. Hey, how's it going? Curious World Aryan. Yeah, absolutely. So go for your bachelor's and then jump into industry as soon as possible. Immediately jump into industry. Work experience is more valuable than a college degree. So if you have a college degree, that is good, like that helps, but work experience is better because you'll work on real world business problems, and they're more focused and more challenging, and you will get more experience. So yeah, I wouldn't recommend a master's degree, just a bachelor's if you could. How will you start ML as a full stack developer? I recommend using something like PyTorch or Keras. Actually, I recommend Keras. I think Keras would be a little bit easier. And then you just kind of walk through the tutorials, and then you're good to go. That's the way I recommend it. That's a good start. Definitely. Thank you for the likes, you guys. I can see it on the screen. All right, let's see here. How are we doing? Okay, so we haven't quite. the main goal of the whole stream. All right, so we've walked through, for the most part, our Rust machine learning framework. I would say we did a pretty good job at just kind of walking through it. So we've got a model, which is a sequential model that combines layers together to create a feed forward and a backward propagation model that allows it to be trained, but you can also use it for inferencing. Any need to learn the algorithm? Sam D. Dev, good question. You can, and I think it's helpful because then you know better what makes sense to use, where and when. Like, what is an activation? Why would you use it? What are the different kinds of activations? What is a feed-forward neural network? What is SGD, stochastic gradient descent? Like, all these things, they all have fancy words, but it's just math. It's just like arrays of arrays, and then you're adding and subtracting and dividing, and that's all it is. That literally is all it is. But there's a lot of fancy words behind it, and I would say it's kind of unfair. I would say these extra fancy words that other people have invented to describe artificial intelligence and, statistics in general is kind of unfair because it's really just simple math at the end of the day. It's just mathematics. It's just adding, dividing, subtracting, and then in loops, and you're looping over things. So it's just kind of unfair because it creates this barrier to entry. And it makes it more difficult, I would say, for a lot of people to start because the terminology is just confusing. When in reality, it's just a bunch of synonyms for the same thing, but they're fancy words and they sound fancy, and it makes it like exclusive, and it makes it sound smart. So that's my opinion on the matter. Just to let you know. So you got an internship? You did? Oh, that's a really good. You got an AI ML internship. Congratulations at Wells Fargo. How should I prepare for it? Any project ideas? That's a really good one. Okay. So you'll probably be using Python. There is my guess at Wells Fargo. Use something like Keras or PyTorch. Build at least. It depends. If I don't even know what level you're at. I don't know. I might be recommending something to you that you're like, oh, I've already done that. So I'm not quite sure where you're at from that perspective. But if you have an internship, then you probably already have enough details there. But yeah, I bet you they use Python of anything. MD, how do you learn programming and suggest for a 17-year-old student? How did I learn? YouTube. I learned on YouTube just by watching people program and seeing kind of what they did, and then trying it myself. Watch and then try. So you watch it on the YouTube, and then you go off and you try it, and then do that over and over and over until you learn. And that's how it works. Okay. So we've got our sequential model here. Let's see here. I think librs is misnamed, but I think this is what we want. This is the main file. Here we go. So we build our model. It is a very small model. Look at this, you guys. Look at how small this is. How many parameters is this? It's like maybe 100 parameters at most. This is like not a lot of parameters. And this is the XOR model. So let's open up a new window here. Let's go to 2. All right. And then let's do cargo build. Actually, let's do cargo run. And then that will run this model. Prompt fail. Would you rather fight a horse or a horse-sized duck or 20 duck-sized horses? Wait. 20 ducks. Oh, well, it depends. I guess it depends on the surroundings. Like if you're in an open field, or if you're in a forest, because you might be able to. I guess if you have to face them directly, if you're facing the duck-sized horse, or the 20 duck-sized horses. Well, yeah, I don't know if I want to fight a giant duck, but the giant duck probably I wouldn't be able to hurt much. But I probably could take on 20 ducks, I feel like. Or 20 horses the size of ducks, I feel like. But it'd still be freaky to see horses that are that tiny. Okay, so check this out, you guys. So this is how the prediction works. You see here, this is our XOR model. It will predict, it essentially predicts the output by training on a bunch of iterations. Each epoch essentially is one entire loop through the data. And there's not a lot of data here. So here's the training data. We'll walk through that here in a second. MD, I learned to code, but can't program more than 100 lines. That means coding and programming is two different things. What do you do to learn here? You're stuck? Well, if you can already do 100 lines, then you just open a new file. And then you've got 0 lines and you make another 100 lines and you're good to go. And that means now you're programming. Yeah, I suppose. So I guess that's the challenge is when you get into bigger code bases. Here's the deal, MD. You're gonna be faced with a tough decision. You're gonna see all these really fancy abstractions that help organize code in different ways, such as classes and structures, interfaces, implementations, overloading. Beware of those temptations. They make your code you think is nicely compartmentalized and organized, but they just make it overly complicated and difficult to maintain. Keep your code super simple. Just have minimal indentation and avoid the use of abstractions. They're tempting. They're a lot of fun sometimes, but guess what? You're going to paint yourself into a corner and it will be difficult. Like you would say, oh, well, we can build this framework this way and then it makes the code reuse and we can apply all these features really quick. And it makes it seem like you're doing a really good job by creating such a powerful abstract framework into your existing product. It's much better just to keep things simple. It really is. Like there was a code base that was so excellently architected. It was 40,000 lines of code. We were able to completely rewrite it in just 3,000 lines of code. And it did the same thing. It did it better. It was faster and it was easier to maintain. So beware of abstractions. They will take over and you will think you're doing a good job, but it actually costs too much in the underrun. Hey, sir, I want to do an internship under you. That's actually a good question. So I did submit to see if we have any openings for internships. I'll let you know. We'll see if any teams have opening for internships. I think right now we don't have any openings, but we'll let you know. And if we do, then I will post it. I'll post any openings that we have to our Discord. So we just got a Discord coming here. Here, I'll paste it, do a link and to the chat here so you can have... we may not. So no, don't get your hopes up. It doesn't look like we have any openings now, but we might in the future. So you stay tuned. Stay tuned. There might be some internship opportunities there. How can you learn Rust in a day, Stephen? I know a few compiled and interpreted languages, and I'm mid-level. Oh, you're mid-level software. Okay, so that means Rust is basically all the other languages. The main problem with Rust is that it has a little bit of difference. It has a strict compiler and it has built-in concurrency and memory safety up front. So some of the design patterns that you've learned from other languages do not transfer over to Rust. So you have to unlearn some things. At least just start with a hello world, of course, and then maybe try to use some of the libraries. I've got your answer though. I've got your answer. Actually, I have a YouTube series. I have a YouTube series for Rust and it's called Rust by Example. Here we go. This is what you want to do. This is it right here. Rust by example. Rust by example. Here you go. This is your answer. This is it. This is the best way to learn Rust. Hands down, undoubtedly, number one, the best way to learn Rust. Let's see here. Is there a, let's see here. Here we go. You can do dark mode. Here you go. Hello world. And it's all built in. It's everything all the way from top to bottom. See here on the screen, top to bottom. It gives you easy to all the things you need, and then it gets more complex from there. And there's a built-in compiler. So you just click the plus button and run, and you can edit the code right there. Hello world. And so I can add some extra exclamation points, and you click play again, and it recompiles for you right there in your browser. And you can see it's running, and then extra exclamation points. There you go. So that's the way to do it. That's absolutely number one, hands down the way to do it. Number one, that's the way to learn Rust. And there is a Rust by example. If you want to just watch the YouTube, you can do Rust by example on YouTube. And I've done that as a tutorial. Let's see if it shows up. There it is. Look, you guys I'm at the top. What do you know? Isn't that cool? Rust by example. There you go. To learn on YouTube, I did most of the Rust by example on YouTube videos. So I did that a couple years ago, almost at this point. Yeah, isn't that cool? Look, I'm a number one on the Rust by example. Who would ever thought? Did you know? I didn't even know. That's crazy. Prompt fail with open router. Okay, sir. Here we go. MD recorded, sir. Thanks to give you some the best advice of today. Thanks. I'm in your life. Excellent. That's so cool. Happy to hear it. Follower for life. Cool. MD. Appreciate it. Absolutely. Sachin, just a quick question. If someone starts today, what should the roadmap to learning machine learning and getting the job in computer science background. Thank you for the likes, you guys. With no computer science background. So that's a challenge. But good news is the best way to learn software engineering is teaching yourself, because there's a lot of mistakes that you need to make in order to understand the boundaries. So self-teaching yourself a language, or in general, self-teaching yourself, is better because you're going to learn the boundaries. If you do just traditional teaching by a course, you're not going to see any of the ways to make mistakes. And the mistakes is what you learn the most by. The mistakes you make help you learn better. And that's why humans have a bias towards negativity. It's called negativity bias. You learn by making mistakes. That's our best technology trait. As humans, we are able to recognize failure. Failure is the best technology that humans have ever come up with, and our ability to recognize it and make things better. And if you need to leverage that in order to learn. That's the best way to do it. So self-teaching yourself and making as many mistakes as possible. There you go. That's it. But you can also, watch YouTube videos to help what's understanding possible, and that helps you along the way as well to learn from others. It's a really great way to do it. Yeah, thank you for the likes, you guys. I appreciate it. This is all so cool. Hey, just a quick question. Okay, yep, we got that. Cool. Thanks. I can learn Rust too. Yes, you can. You can totally learn Rust. This is the way to do it. Rust by example. Just click on this and we're good to go. I'm wondering, let's see. I'm going to click on it and it will probably be me talking. But this was me a little while ago. Here we go. I will. Oh, wait, no. It's going to play an advertisement. Don't do it. Don't do it. Exit. Left. There we go. Okay. Here we go. Oh, I missed your question above. Oh, sorry about that prompt fail. Repeat your question. I'm trying to keep up with chat. I'll definitely try to keep up with chat here. You started with RU because of Nautilus trading. Never realized how lucky it was. Oh, cool. Definitely. Can I learn and get up to speed in a day? Xiam, up in a day. Rust by example? Yes. With Rust by example, absolutely. Because you will get started in a day, no problem with Rust by example. When I started learning Rust, it was before there was even docs. Like I learned Rust, more than 5 years ago, 6 or 7 years ago at this point. And it was like the early days of Rust. So there's better resources now, and do Rust by example. That's the way to do it. Rust by example. Hey bro, you're from India. Excellent. Ravindir. Hey, Ravindir. Let's see. Let's get back to the code here. And then we will wrap up. All right, so here we go. This is our model, and it trains on the XOR operator, as you can see here. This is the training data. Here's the array. What are some projects that you recommend for new programmers? To-do list. The to-do list. Build a to-do list. That's probably like a really good hello world, because it requires you to understand different cycles, then create, read, write, update systems, the way to store data, the way to receive data from user input. A to-do list is a really good way as a beginner project, the to-do list. Before ducks? Oh, it was before ducks, so you have to repeat the question because that's way up there in my chat. Between Rust and C++, which should you learn? I mean, Rust is gonna, so they're both, here's the deal. C++ is more prevalent, and it depends on what your objective is. Emmanuel, it depends on what your objective is, Emmanuel. If you were looking for more jobs are in C++, but Rust is up and coming. It's the world's most popular and loved language. So Rust is there if you want to get ahead of the curve. And get started learning Rust is probably better because C++ is getting left behind. Rust is taking over from that perspective. But there's still a lot of C++ jobs out there. Okay, so here's our sequential model. Very tiny model. So what you can do is you can even increase this. Like you can bump these numbers. So you can say 5, and then you can say 6 here. For example, you can double the import, and then we'll rerun the model, and it will train a little bit more slowly because we have more neurons to build through. Isn't that cool? You're learning Python. Python's actually really good because it's the premier language for AI. Learn Python. The premier language for AI. It is by far the best. Undoubtedly, number one. Docs, not ducks. Okay. Yeah. There we go. Oh, wait. It panicked. Oh, it panicked. I know why. Here, it panicked because we don't have... Here's why. Check this out. When you're passing data between layers, you need to make sure that the the ending number matches the following number on the line here. Because it's a matrix multiplication that's done through a transposition, which just means you're rotating the matrix, and then you're doing matrix multiplication again on the data. And so you got basically your input and output. So you got your input size, your output size, and then that needs to match here. So if you wanted it 6 here, you have to put it 6 here, and then it won't crash. Boom. It's going to take some time there. It's going to run, and I bet you guys it'll work now. I bet you it'll work. You're going for Rust? Excellent. Sumit. Hey, how's it going, Sumit? Good to see you. Happy to have you here. It's great to... oh, wait. Hold on. No, I swear it was supposed to work. I was Oh, I know why. It's because I forgot this. The input layer has to also match the input layer. Okay, so this has to be 2. Why does it have to be 2? Because our input layer is 2 here. So I missed one part. I missed that part, you guys. All right, now I swear. I promise it'll compile and run this time. It'll work this time. It will. It'll definitely work this time. No doubt. I'm going to sit here, my hands off the keyboard. It'll work this time, and you'll see epochs starting to train. There it goes. Did it crash? Nope, no, it didn't. You're seeing the epochs train. And it's taking longer this time, and it's got more neurons. That's because we've added density to the model. We doubled the density between the layers. The hidden layer is double the size. And look, you can see that our accuracy is improved just a smidgen too as well. So you can see here, our accuracy is just a little bit better. So now that we have our XOR, and you can see that we're kind of playing with the data. One thing I wanted to do before we end stream, so we do have to end stream here pretty soon. But not right yet. We have one last thing that I wanted to achieve. And that one last thing here is to build a Threven and Throd detector. We're going to build a Threven and Throd. That is a sort of an odd and even, but with divisible by 3, you know? That's what we're going to do. Sachin, hey, I really love your energy and way of explaining things. Oh, thank you. Yeah, see, Sachin, here's the deal. Most language, especially in the computer science world, is overly verbose and fancy. The language is so fancy. The deal is, it really is actually simple. You do not need to use those fancy words. For the most part, it's just data, maybe some loops, and some if statements here and there. It's not that you don't need to have this advanced, complicated terminology to help you understand how to build very effective, powerful, and performant code. You do not need these fancy words. You just don't. It's just not necessary. So here we go. So we've got our model that we doubled in size just for fun of it, right? We can also add more epochs. Let's do that. I want to add one more. I want to add a little bit more epochs to it. Here we go. Let's double the epochs. And what we're going to see when we do that, you can see here that our prediction has a range between basically 0 and 1. Right here at the bottom, the prediction 0 and 1, you can see. So if it's close to 0, that means it's 0. If it's close to 1, that means we can consider it 1. And that is our answer. And so you can see how well the model has learned, it's trained. When we do this and we double the number of epochs, do you go live daily? Yes, I go live daily, except for on Saturday and Sunday. I rest. I take a break on the weekend. But on the weekdays, I go live. So it depends, though, right? MD, like you've been here already. I have different meetings scheduled throughout the day, so it is challenging for me to go live at a consistent schedule because I have work, and I can go live when I have time in between those, and so it depends on the week. So to get subscribe to get notified, but you could also get on our Discord here, and you can get notified when the live happens. I'll paste the Discord here again. When I go live, because it's random. We go live, but I definitely go live every weekday is the plan. Prompt fail. Do you think AI could become more conscious? It has been showing hints of consciousness, right? It has. I think it's going to be conscious if we get to quantum computing, because quantum computing is a lot more like your brain. Your brain has 100 billion neurons, right? 100 billion neurons. And we've tried. Oh, prompt fail. You just subbed. Thank you. Good to have you. Your brain has 100 billion neurons. Yes, you're going to join the Discord too. Cool. Thank you, MD. Excellent. So with your 100 billion neurons, it's not the same as saying like 100 billion parameters in a model. So like the AI model, like ChatGPT 4 had 1 trillion neurons essentially, right? A trillion parameters, but it's not the same because your brain is more like a quantum computer in that fashion, right? So your brain has this like quantum effect that is different than the mechanical effect that we're emulating with the ones and zeros. But once we get to quantum computing, you'll be actually calculating on molecules, which is the same as your brain. That is when we'll have consciousness, I think. Or if we get the compute to the point where it has enough density, so you can have like 100 trillion parameters maybe on a really powerful GPU that hasn't been invented yet, then we'll also have synthetic consciousness at that point, I think. But it won't be quite the same. Yes, so, sir, while learning languages, what should a person focus like learning only one language and perfecting it or learning multiple languages? Here's the deal. Sachin, here's the deal. Every language is essentially the same. They're all the same. I recommend learning Python because it's easy to read, and it has all the same design patterns that you have in every language. Flow control, if statements, and checking ranges is something equal to something else. Python has that, really simple, right? And you have for loops, so you have iterations that allow you to iterate over lists. And then there you go. That's like the main compute. That's it. I mean, if you're looking at the screen right here, you can see that we have a for loop, right? The same in Python, and then we have some flow control here, right? Because you don't want to print out every epoch loss. You only want to print out every 1,000 epoch losses, right? Every 1,000, because you don't want your screen to get filled up with a bunch of rapid things that's hard to read. You want to keep it readable. Because whether you see a job posting here is so much requirement how a person can learn so many things as a beginner. Forgive me for the questions are so naive. It's totally fine. You're totally fine because you always got to start somewhere. And the hardest thing to do is 0 to 1. 0 to 1. That's the moment you get started. Open up YouTube and start watching a YouTube of someone programming, and then work and start with there, or try opening up a terminal window and then coding there. That's the 0 to 1. That's the leap you got to make. All you have to do is make the leap. And it's the same kind of leap whether you're learning to program or learning something else, learning artificial intelligence, maybe learning to start a business. It's all the same. Isn't it? Isn't it cool? I'm going to run this really quick so that way we have this running here and then I can get back to you. Oh, Emmanuel, as someone who just got into machine learning and artificial intelligence, what projects would you recommend to get an internship? So generative AI is probably really popular. If you have the ability to rent a GPU or use transfer learning, actually, here you go. Here's your project. I've got it for you. Are you ready, Emmanuel? Do distillation. I recommend distillation. So it's actually pretty simple. What you do is you have an AI distillation. Well, this is a fancy word, and it's a fancy word, and it looks really good on your resume. Distillation. Here we go. Which just means, actually, just spell it right? I got to spell it right. Distillation. There you go. It's got 2 L's. This lets you use a large model, like an LLM, and then you use something called tool calling or tool use to get back deterministic response output. And then you have it look over a bunch of documents or images, and you ask it questions. You say, is this image green? Or is there green in this image, right? Is green in image? And then the big AI will take that data, read it, and then give you a deterministic JSON serialized output, which you can then capture that data as your training data set for your small model. And then you build a model like we're building here in Rust or PyTorch, and then you can train a small model and use the big model that trained it. Isn't that cool? Isn't that cool? That's the best project, Emmanuel. You will get like top of the ranks, I believe, if you do distillation. I think that would probably be one of the more impressive things that you could do, but it's also pretty straightforward. It's a multi-process. It's you collecting the data, asking the AI questions based on that data, and then getting the output, and then you can train a small model on that output, and guess what? With that small model, we'll be able to accurately answer those questions, but at a fraction of the compute. That level of savings is what you want to put on your resume, able to create a new model that is 1,000 times more efficient. Wouldn't that be cool? That sounds impressive to me. I think that sounds cool. Synthetic consciousness would be far step above 90% of the world's these days anyway. Yeah. You're right. There's a lot of humanity that is very happy just going about mediocrity, and they're okay with it. And that's okay. Now, what I want to get to is the Star Trek Society. Star Trek Society has no currency. Everyone can do anything they want because there's such an abundance. There's such an abundance that, they have things called like replicators that you just say, hey, I want a sandwich. And it will boop, 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 boop. There you go. You got a sandwich. But you need a lot of energy to synthesize the matter for that. So they have, what is it? Certain types of engines that they have that essentially limitless energy. But we're getting there as well. We're on our way to building those types of energy generators. Clean energy. It's called fusion. That's what it is. It's called fusion. And it lets you fuse together, say, like molecules to create like helium. For example, like hydrogen into helium. And it's different than fission. Fission is dangerous because it creates radiation, and that's what the nuclear reactors are. It's splitting the atom. That's what fission is, splitting atom. But energy, 0-point energy, prompt fail. Yeah, there's energy all around us. Quantum particles coming in and out of existence. If we can harness the fabric of the universe, 0-point energy. There you go. That's the way to do it. There you go. That would be amazing. So if you were to, say, invent a way to harness this 0-point energy, you would gain a Nobel Prize. You would, sir, would win. You would win at life. 0 to 100 was network Chuck for you. Yeah, it was network Chuck. Cool. Sachin, sir, can you please explain what you are building today? Yes. So we've got a machine learning model that is just a simple. Here you go. See all these files here in the source directory. This is it. So you can see here on the screen. I'll highlight it. 1 second. I'll highlight it with my cursor. There you go. See, we've got 1, 2, 3, 4, 5, 6, 7 files. We've got 7 files there. And these files are just basic vanilla Rust with few dependencies, and it's a deep learning machine framework. Isn't that cool? It's a custom machine learning framework. And here it's open source, and it's a good way to get started. I'll paste that here into our chat so you can see it. And it's running in Rust. So it's actually really straightforward. But that's what we're doing. We're playing with it, and we're going to cook. I want to go one step further. So we just changed some of the parameters. We changed the number of epochs. Oops, here, 1 second. Let's get the screen back. There we go. There we go. I want to modify this. I want to do a Threven or Throd, and then we'll end stream as soon as we accomplish that. Kurt. Hey, Kurt, how's it going, Kurt? If Rust is such an impressive programming language, why does it seem to have relatively lower demand in tech companies because it's new. It's new. And the demand that tech companies have today is an existing, because they have debt. It's called debt, and it's code. Code is debt. They lease their debt to other businesses for revenue. That's what we do at PubNub. We have a bunch of debt in C and Rust and Python, and we lease our debt in the form of an API that other businesses can use to enable communication. So we have a communication API that you can use to build with your phone, to a laptop, to a web browser, to an IoT device, to a TV, a smart TV, or a console, a gaming console. So we have SDKs that let you create communication no matter what network you're on or what IP address you're on. That is what most businesses have, right? They've got this debt, and they're going to hire engineers to manage that debt for them. And that's why Rust is a newer language. But at PubNub, we have a lot of Rust. And so we really like it because it helps us maintain a minimal debt. It's the best for that. And it is slowly taking over C, for example. Python is going to be the language to learn, though. I think it's the most prevalent language from an AI perspective. And it can still leverage Rust and C by importing those libraries directly. And it makes it a really easy way to build your coding, but also leverage the power of those frameworks. You can still do it, and that's what libtorch is with PyTorch. There you go. Prompt fail. I'll follow you on GitHub too. Thank you. Glad I scrolled into you today. Cool. Glad to have you here. Appreciate it. July Ort Solana. Yes, a blockchain that supports Rust with WASM. Inspire through knowledge. Hey, how's it going? Pip you. How's it going, my friend? I'm 22 and I want to become a programmer mainly in the AI and ML. So if you were ever to start, where would you start a career path? The best advice. Good question. So there's multiple approaches. I do recommend what's called Python. You want Python? It's called I think SciPy. What is that? SciPy is Python for it's simple. Start with simple machine learning first, and then you can get into deep learning. Scikit, I think it's called Scikit. SCI Kit Python. Here you go. I always put the G. Here you go. Scikit-learn. This is a nice, simple to use framework, but here's the problem. There's a lot that goes on here, but it gives you all these visualizations as well to do classification, regression, and clustering, which sounds complicated. Don't worry. It's just numbers on a spreadsheet. It's okay. It sounds scary. I know, but they are just numbers. They're just numbers on a spreadsheet. Don't worry. And you can analyze those numbers using these algorithms, these nearest neighbors, logistical regression, and then other things. What I do recommend though is my favorite thing in Scikit is SVM. Yeah, Scikit-learn. Thank you. Absolutely. July Ort Scikit-learn. This is a good place to start because it's a lot funner and it doesn't require a lot of hardware because it can run on your phone. It can even run on your phone. Scikit, Keras, and TensorFlow hands-on. Oh yes, Not Owen. Thank you, Not Owen. Not Owen has a bunch of recommendations there that are fantastic. Copy and paste every word that Not Owen has posted there in the chat and write that down. Those are things that are really good to get you started for AI and machine learning. Absolutely. Excellent. Not Owen. Thank you. By far. Okay, so here's what we're going to do, guys. We're going to wrap up today's stream by doing a Threeven and Throd. Here we go. I'm going to close that really quick. Actually, there we go. Open it back up. And then we're going to do a Threeven MD, same as PP17 or same as PyPy or Pippy. I'm not sure how to say that, but you want to learn how to build projects on blockchain. Oh, and ZKP. Please suggest a path for me. Okay, so it depends on which blockchain you're looking at, MD. Which blockchain are you looking for? So you can do Solana on Ethereum. You can do Rust, not Solana, Solidity. I got to get my words right. Solidity with Ethereum. Thank you for the likes, you guys. Solidity is an ECMAScript on ETH. Or you can do, I think you can do Rust WASM on Solana. I think Solana. Is that spelled right? I got to spell it Solana. Here we go. Rust and WASM on Solana. I would say, yeah, Ethereum on ETH. Thank you, sir, for answering. Hopefully Rust will take over. Yeah, Kurt, it is on its way. And I tell you, we've invested a lot into Rust at PubNub, and it has been so worth it. The advantages that we have over everyone else in the market by having our infrastructure powered by Rust is just... It's quantifiable, but it's astounding is what I meant to say. Sol is Rust native. Is it? Okay, cool. Are you native? Excellent. So that would be a good way to build smart contracts because here's why. Smart contracts, you want to make sure they're stuck in it forever on the blockchain. And so before they're deployed, they need to have a sort of a check or a parity check that says, hey, is this program good, right? Is it good? Because we don't want to have a bunch of, non-working smart contracts on our network because it could cause problems. So Rust has a lot of strict compilation strategies that make it a really good candidate to be a smart contract language. So that's really cool. Okay, here you guys, we're going to write a new function called fn get is odd or even training data, odd or even data. I think we just do this, boom, and we want to do the same thing here, like this, and then copy paste. Actually, we'll do something. Well, let's copy the whole bit here, like this, and then we just want to grab that like this. There we go. Comment some of this stuff out because we're going to change it. We're going to make it different. // Okay, here we go. Jambuster. I think Keras is also an easy, yes, Keras is really great. Jambuster, thank you for recommending Keras because you can use Python with it, which is a very simple and easy, and it's a friendly language. I still use Python every day. So I love Python. It's great. And Keras is also one of the easier to use deep learning machine learning frameworks. And it also supports generative AI as well. So it's really good to do that. That's a really good. July, I hope you are. I hope is not. Are you for Russian? Oh, Solana is Russian native. Is that what that meant? Is that what you meant? Prompt is not Rust, but is Russian. Is what I think. However it is, that's how it has to be. We're all humans. We're all scientists. The nation that we're in is just just where we ended up. But scientists, no matter where you are in the world, you are important to humanity. So don't let that bias anyone based on your nationality. You are still a scientist. So you are a positive influence on the world. Continue to learn, no matter where you're from. There would be no meme coins if that was required. Yeah, that's a good point. Never odd or even. Palindrome. Wait, hold on. What? Wait, a palindrome is not odd or even? Wait, are you serious? Oh, palindrome. Wait, it can't. Something always has to be odd or even. It's one or the other. It's a binary, right? No, Solana uses Rust. Okay, yeah. Solana uses Rust. Yep. MD, thanks again. Learned so much today. Thanks for gonna learn Solidity and Rust. Okay, cool. Yeah, Solidity is really cool. So I built probably. So I'm gonna brag to you for a second, but I'll have to find it. I built one of the first smart contracts that allowed you to create your own token on Ethereum, and it was an ERC20 token, and it was actually leveraged by a lot of people over the years. I think over 600 different tokens and chains were built off of that code I wrote in Solidity many years ago. I think it's like in 2014, like more than a decade. Crazy, right? Palindrome came back and forwards when you spell it. Oh, right. Same backwards as forwards. That's right. So I learned everything by doing. It will work for Rust too. Yeah. So you learn by doing, make mistakes. It gets frustrating. You get frustrated, you'll be like, darn it. And then the Rust compiler will try to help you along the way. It'll give you recommendations. You'll implement those recommendations. And guess what? It will say you're still wrong. So it just takes patience. Just take one step at a time. One step at a time. As you saw, we were even hitting errors up here. Like, look, I was already hitting errors, right? Like main thread panic problem. There you go. It's because our inputs are incompatible. So there you go. You wrote ERC20? Yeah, I did. I wrote one of the first ERC20 smart contracts that were leveraged by many ERC20 tokens. I wrote one of the first ones. I'll have to find it. You know what? I want to find it. Here, let me see if I can find it. GitHub, Stephen LB, ERC20, Solidity. I think that's all you have to do to type in Google. I'm searching it in here, Google. Stephen Blum. Yeah, I don't have a public repo, but I have a gist because it was in a gist. It was a GitHub gist. Let's see here. GitHub gist. Here we go. Gist. There we go. I'm searching for it, you guys, and I'll paste a link to it. While a GitHub gist from Stephen specifically for an ESR, it's there. I swear. I know it is. Google couldn't find it, but I will be able to find it for you. I'm searching for it really quick. I'm going to find it. I'll find it for you guys. What I'll do is I'll just go to GitHub gist directly, gist.github.com. I've got it open up in another window over here because I've got secrets there that I don't want y'all to see. So that'll load up here. What have we got? Let's see. ERC. Let's go ERC user Stephen LB, and then we will say ERC20. Perfect. All right. Let's see if that pulls it up. I found it, you guys. I found it. Here we go. All right. I'm going to pull it up here. I'm going to pull it up on the screen. Check this out. All right. This is one of the first ERC20 tokens. When was it created? We're going to find out. Let's see here. It says, is there going to be, it doesn't say when it was created. Well, actually we can see some of the comments here. Okay. So one of the first comments was in 2020. Okay. So this is about 5 years ago in this case, is when, and so the cool part about this token in Solidity, is it is modifiable. It lets you make adjustments. So it's like what do you call it? it's easier to make changes over time, I think. Yeah. So jumping back to some comments here. Wow. Yeah. Anyway, the Rust is Burn AI deep learning framework, but it makes you define every detail. Still is mature, I think. Yeah. Absolutely. Yeah. It's I think so. Or not mature is what you said. It's still early. Like I would say, right? Smart contracts, blockchain, ERC20, like all the stuff it's still pretty new. So, how good are you at everything? You talk about all of the techs. How are you good at everything? It's just many years. You run into it over the years. Also, you have to be curious, understanding like what does this do? What does that do? Here's one of the things. I do have questions for you guys. Before we end stream here, I want your opinion. What should we work on next? Let me know what we should work on next. Christopher, I'll let you know what we're currently working on some Rust deep learning. That's what we're doing. But I do have a question for you guys. And then also paste your answer into Discord as well. So I'll paste you the Discord link here really quick. Clicking buttons. Here we go. So my question to you guys on chat on YouTube here: what should we build? What should we build next? What should we work on? It's like one of my ideas that I think would be a lot of fun is to jump into assembly and use assembly and leverage some of the more advanced operator codes symbols, operator symbols to build accelerated computing of some sort. I think it would be a lot of fun to build an assembly compile it and run it. I think that would be cool. Next lesson, social skills. Yeah. Caleb, you're new here. Cool. We're currently working on artificial intelligence and a Rust tutorial. That's what we're doing. That is the current thing that we are working on. Jambus, do you think millions of tokens are exchanged in cryptocurrency and this is futuristic exchanges? Yes, we're in the future because it's a public ledger and it's essentially fully auditable. It's a complete audit trail. Whereas, all the banks, all the transactions that occur in banks, there is an audit trail, but someone can, modify those things, right? They can make changes for you and you would never know. You'd never know. But yeah, so Caleb, great to have you here. We're doing Rust and machine learning, and before we end stream, because I do have to go here pretty soon. We do have to end at some point. I wanted to make an odd or an even. We're gonna cook. We're gonna cook with this model, with this AI. This middle little AI assembly is like a black hole. MD, it is. It's kind of scary because no one programs in assembly these days, but I think it would be kind of fun to learn. I know it a little bit, but I don't use it in my day job. So this would be more of an adventure and more of a fun task by far. Caleb, how am I going to pick up when I just started? Oh, how are you going to pick up when you just started? What do you mean? Actually, that's a really good question. Caleb, what do you mean? How are you going to pick up when you just started? Or you can say, where do you start? We can also do that. Can we work on DevOps or AI ops? That's good. So you're thinking like Kubernetes or containers, 12-factor, event sourcing, metrics tracking. We could do big data, DevOps. There's also security. Okay, so these are good topics. I like these topics. We can build containers. We can orchestrate those containers with HPAs, like horizontal pod autoscalers. We can so that way your code can autoscale in a fleet. Where do you start, Caleb? It depends. Are you looking for artificial intelligence? Are you looking for starting software engineering? Because there are two different paths there. Yeah, that's more like it. Cool, excellent. That's good to hear. Appreciate it. Okay, so these are really good ideas. Okay, so let me type those ideas here into our Discord. So some of the ideas that came up, let's pipe those into Discord here really quick. Here we go. All right, here's our Discord. All right, some ideas that came up. Ideas. There we go. Type ideas for stream. We've got what was it? DevOps, right? Someone said DevOps. DevOps, and then AI ops is also a good one. Ops. We also had security with a crypto, like encryption. We'll say security / encryption. I like encryption. I think that one's a fun one. Encryption. We can also do assembly, assembly. There we go. We can do assembly. Another one. Another project goal for Temple OS. Next project goal for you, Temple OS. What is Temple OS? I'll type that in. Temple OS. I don't know what it is, but we'll find out. We'll find out. Something to do with assembly. Not Owen. Perfect. Yes, we'll do it. Not Owen. Definitely. Unstoppable Gaming. Hey, how's it going? Happy to have you here. We're just typing in some ideas that we'll have for upcoming streams. That was sort of like the question. These are really good answers. I like them. So Sachin, as a beginner, I wanted to create a practice project and show it to you on Monday when you're online. Can you suggest a small project? So it depends. If you're a beginner, build a to-do app. It's called a to-do app. So build a to-do app. To-do app. There you go. Build a to-do app. I like that. What is Temple OS? Yeah, July Ort. I don't know. We're going to find out though. Just a beginner in coding. So how am I going to start? Build a to-do app. Watch some YouTube tutorials. I recommend Python. There's also Python's probably the easiest to get started with because it's contained and it's you'll learn some of the common patterns. Steven, you're a brother from another mother, buddy. Excellent, Shiam. Good to hear. Thank you. Appreciate it. That's high praise. I appreciate it. I love it. Thank you so much. Christopher, can this be anything? I'm a mobile dev. Do you have anything related to that? Mobile dev. Okay, so yeah, you can mobile development. So in that fashion, you're probably talking about a Kotlin or Swift, right? You're going to build Kotlin or Swift. And if you're a mobile dev and you're trying to get started for mobile development, building mobile apps, the to-do app is still the best way to get started, I recommend, because it requires you to have a user interface, logic. You can do user input, validation. It's just a ton of stuff all in one. So I think it's really powerful. You give everything for free and great advice. Thanks for all of us. Yeah, absolutely. That's knowledge. We got to share knowledge. We got to advance humanity. Let's take humanity to the next level, I think, by sharing everything. All the knowledge, all the years and decades I've had in computer science. I'm happy to share that with you all. By far. Thanks for all. More success to your work. Thank you. Indie Dev Dan is pretty good resource too. Yeah, you got it. Indie Dev Dan is a fantastic resource. Definitely look up YouTube. There's a lot there as well. So these are our ideas. I'll pipe that into here. Okay. Now, before I end, because I do got to get going, before I end, I want to finish this is odd or even. We got to do is odd or even. Let's see here. Let's see. X train. We want it to generate some random numbers. So how do we do random? Okay, so we'll say random lists of numbers and between 0 and we'll do like 100 or something. So X train. Let's see if we can coax the AI in here. I might not. Let's see. Let's double check. Copilot. Or we'll just have to copy paste from the internet. Copilot. There we go. Is it going to work? Synthesizing. It's thinking, you guys. 0 completions. Oh, come on. That's ridiculous. Okay. We can. So there is some existing code in here that I can copy and paste from. This is the way I like to do it. I think it is in layers. Here we go. Random. Perfect. This is what we want. We'll do it like this, you guys. We'll do it like this. X train. Boom. Boom. There we go. All right. So I've got that. And we have, we did. Okay, cool. All right. Gonna jump back to chat here for a second. I just had to type a few things down. All right. So we've got Flutter. Oh, Flutter, right. I forgot about Flutter. Flutter is also a really good language for cross-platform development. Yep. You can also use Xamarin and Unity and React Native. Those are some other options as well. Terry Davis, Jambuster, excellent advice. Terry Davis, yep. Zhao Lin Toon, I'm learning from scratch. So like how much time should I dedicate to learning? How much time? As much as you can. Like it's a forever thing. So Zhao, it will be a forever thing. I'm still learning, right? And I've been doing this for decades. So Zhao, it's just a forever thing. You always have to be learning, and new technology continues to come out. So it's just like a continuous thing. MD, okay, bye, sir. See you around. Yep, we're heading out here pretty soon. Can you use Copilot chat inside NeoVim? Yes, you can. MD, it was good to see you. Christopher, is Xamarin still being used today? Actually, I don't know. I thought it was, but it might not be. it's probably better to use something like React Native or Kotlin. Not Owen, you must never give up. Yeah, never give up. It's a persistent, always learn. Always learn, not Owen. Yep, you got it. Absolutely. So let's see here. We've got our random input. So we're going to do int uniform and then, okay, so that's the uniform, but we want it between 0 and 100. Let's see here. 0, 0. So do that. Let's see if that works. And then we'll see if we can, here we go. We don't want that there. We want that over here. Perfect. Boom. Let me go. Let's comment that out really quick. There we go. We'll just do train Y. There we go. I do believe that's it. So, and then I want to print this. I want to print that out. Get odd or even. Like you meant for today, always learn. Oh, yeah, for today, give it a good hour, right? At least give it a good hour. .NET MAU took over Xamarin. Oh, did it? .NET MAUI, MAU UI, or MAUI. I didn't know. Okay, that's actually good to know. Thank you for that. We're learning new things here. We are learning new things. All right, here we go. Build model. Here's run. Okay, so I want to, we'll just say return. We're not going to do any of those things. We'll have some unreachable code, but that's totally fine. And we're going to paste this, get odd or even, and then we want to, yes, we want to do that, but we'll do it like this. Boom, 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 pop. There we go. And then I want to print. Yes. Oh, here we go. Print. Let's see. We'll say print these guys. Here we go. Boom. All right. So here we go. Perfect. All right. Now let's see what that does. Let's do our cargo run, you guys. All right. We're almost done. All I want to do is create a quick. Okay. I will see. Oh, it's not. It doesn't like that. Why isn't it like that? Get odd or even. Why doesn't it like that? Okay, let's see. See, we're coding here, guys. We're actually coding. We see some errors. Oh, I see. Okay. Got it. It doesn't like how we did it. So I suppose. So how are we going to do this? Because isn't it not an array 2? It is an array 2. It's a float 64 array 2. That should totally be fine. Why doesn't that like that? Unreachable statement. Oh, yeah. We don't care about the warnings. We don't care about the warnings. We only care about function associated item array base owned. Okay, got it. Christopher, for cross-platform, I think Kotlin multi-platform. Yeah, Kotlin multi-platform. Absolutely. Pure native UI for iOS and Android. Built everything in Kotlin, even the backend. You can do backend Kotlin. I didn't know you can run server code with Kotlin. That's actually kind of cool, Christopher. I didn't know. We'll keep trying here. So I think what we could do is we'll just keep things simple because I want to keep things just simple. We'll get it going here. So we'll do something like right. We don't need it. Just needs to be. It's a 1 of 1. So we just need it to be like this. Here we go. Let's just copy paste that really quick. There we go. Okay, and then it needs to be like this. And then our model is going to be a 1 and 1. So it'll be like this. We don't need a 2. It'll be 1 and 1. And let's see 1, 2. We're just gonna make it simple here. 3, 4, and then we'll just keep going like this. We don't need the dot though. We don't need the dot. Actually, we do because it's a literal, right? It needs to be a floating point. Yes, definitely. Yeah, cool. Oh, cool, Chris. Yeah, it is. That is. So Kotlin multi-platform. That's the way to go these days. Absolutely. So here we go. Let's copy and paste this. So we're just gonna do a few more, and all I want is to ensure that here we go, paste. So we'll do some training sample here. So 4, 5, and we'll go 6. We'll do 7, 8, and then 9. Perfect. Okay. So we'll just keep it simple, and then we will do odd and even, right? So 0. We'll say 1, right? And we'll go 0. Actually, no, 0 here. Are you making your own AI? Yes, that's what we did. Spicy Chip 12. Spicy Chip 12. We made our own AI, and we're playing with it now. We're gonna cook. We're gonna do is odd or even. We were thinking throd or threeven, but we're at the end of stream time and I got to get going. So before ending, we gotta make this right. So odd and even. So 0 is actually an even number, and then 1 is odd, right? So 2 is even. 3, we'll do 3 here. And then we need 4. Let's get 4 as well in here. We're gonna get 4 going. We're gonna get all the numbers, every number. We got to make it fair. Here we go. And then what we can do is we can just copy paste this here. So we just do it like this, copy paste into here, boom, 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 boom. There we go. So now we've got our input and our output. So we know here we've got our numbers 0 through 10, or 1 through 9, or 0 through 9 basically. And then we know what the data, and so now we're going to train an AI model to predict the future. And I'm curious, I'm wondering if it, because this is kind of I think you can solve this with linear regression, but is it going to be able to detect odd and even numbers beyond 9? See here at the screen, we got beyond 9. So we'll try it. We'll see if it can predict it. I'm pretty sure it could, but we'll find out, right? We'll find out. All right, here we go. Let's see if we can cargo run. Is it going to run this time? I don't know, you guys. You missed the trait random ext. Oh, is that what I did, July? Got it. Okay. Understandable. Let's see here. Let only supported directly in conditions of... Oh, wait. No, wait. What do you mean? Let's see here. No, I'm doing it the same way I'm doing it here. See, this is why Rust is one of the challenging languages. Hey, thank you guys for the likes. I appreciate it. We're actually coding now. We're actually coding. So let's see here. Let's get there. Let's hide this so that way the compiler doesn't worry. Let's see here. Then we want to print. We want to print it. Get odd or even. I'm pretty sure. Oh, yes, we returned it. Here we go. We returned it. All right, let's see if we can get that going. Let's see if that works this time. I don't know if it will. We didn't really change much, so I guess we'll find out. I mean, it counts. This is array 2, so... Oh, we only got warnings. We only got warnings, you guys. I think we did it. Christopher, so refreshing finding a live stream that's like-minded individuals. Love this. Cool. Yeah, absolutely. This is exciting. This is the kind of things that I just do for fun, right? You just do this for fun. And you know what? It's like, instead of just doing this on my own for fun, why don't we do it live on stream? Then we can share it with you guys. So we can share it together and then we can enjoy this exciting adventure at the same time. All right, so we did it. Here's our training data. And what we can do is now we can train a model on this data. Check this out. So we should be able to easily, and so I changed our input model to be a sequence, so sequential. So input size is 1 because it's just a single number, and then output size is 1 because it's whether it's odd or even, right? And binary classification. As a self-taught guy, I really want to get into Rust, but it's hard. It is, Victor, it is so hard. Like, I was struggling right now, and I've been using Rust for a long time. Christopher, what do you mostly work on with your day job? Our engineering teams and sometimes me, we use Rust. We have C, and we distribute our code over Kubernetes across all of Amazon's availability zones that allow you to connect to the closest region to enable communication for devices like your mobile phone, your smart TV, your console. Like, we've got PlayStation, we've got Xbox, we've got Switch, and we've got Unity, we've got Unreal Engine. We've got, obviously Python, Rust. We've got SDKs for every platform, basically. And that allows you to communicate no matter what your IP address is. Anywhere in the world, your IP address doesn't matter. We can get data to that device in real time, usually in about 30 milliseconds. But, depending on the distance between the devices, it could be up to 100 milliseconds. But it's really fast. Victor, same boat. Hey, let's learn together community. I'm starting from tomorrow. As per Steven's advice with Rust, Shyam, enjoy. It's adventure. Definitely Rust by example. Do Rust by example. Shyam, yep, Rust by example. That's the way to do it because you don't even need a compiler because it's all right there in the thing for you. Rust by example. There you go. Do Rust by example. This is the way to go. And if you want some YouTube videos, you just click on the video link there and look, I'm at the top. I'm right here at the top. Rust by example. I went through most of the Rust by examples. And so you can do that. But yeah, Rust by example is the way I learned Rust as well. But for the more advanced features of Rust as they came out. So I learned before Rust was, it's still a pretty new language, but there's a lot of great stuff here. Like it's really great. It's like you've got this easy, you click the button and it compiles and you're good to go. Rust by example. Doob the Goober, this is really neat. Cool job you do, boss. Excellent. Thank you. This is great to hear. Okay, guys. Oh, wait. Mega, I missed your chat. DevOps or cloud engineering? Both, right? This is both DevOps and cloud engineering. Victor, you learned C++ and C# by myself. It couldn't be harder. It is. It's so hard, isn't it? Software engineering is a challenge. It is by far. It's a big challenge. This is so cool. But good job. Those are hard languages to learn. I'll try that tonight and watch some of your videos. Cool. Thank you. Appreciate it, Victor. Excellently. Grigory. Hey, who is better, Rust or Go? They're about the same, I would say, right? So if you're going to get a job in computer science or software engineering, you want to find a role that has, a popular language. The more popular languages are JavaScript, of course, TypeScript, Python. Those are the more popular languages. And then it goes to C, and then maybe Go and Rust and Java, right? Java or JVM languages like Scala, things like that. Victor, kudos. Yeah, good job, guys. Do you stream like this often, Christopher? Only on the weekdays and only for about an hour on the weekday. And it varies. I don't have a schedule because oh, wait, you guys, hold on. Am I missing a meeting? I might be missing a meeting. Wait, oh, wait. Yeah. Uh-oh, you guys. I have to go. I streamed for too long, you guys. Sorry. 1 second. I have to go. 1 second. Okay. Okay. I have to go. Sorry. I streamed for too long. Sorry. We'll have to finish this another time. But it was great to see you all, guys. Thank you for hanging out. Join the Discord, and here, let's get you guys going. We'll get you on the Discord, and then you can find the stream again in the future. But I went too long, and I'm late for a meeting, and I'm embarrassed by it because I'm usually really good at that. But here's the Discord. But also subscribe. Thank you, guys. Thank you. See you, everyone. Enjoyed having you around and chatting with you today. Had a lot of fun. We'll be back next week on Monday. Have a good day, everyone.